Hello, and welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Jari Cook of JPL's Media Relations Office, and I'm going to be the moderator today for our wrap-up news briefing for the Cassini mission to Saturn. About an hour and a half ago, very early California time, we bid farewell to the intrepid Cassini spacecraft. It plunged into the skies of Saturn and ended its mission. To help us understand these last moments, we have some key team members with us today to share their thoughts. We do have some reporters on the phone, and so if you have questions, you should press *1 on your telephone. And we're also going to be tracking questions via social media, and you can use the hashtag AskNASA. So to kick us off, I'm going to introduce to you Michael Watkins. He's the director of JPL, and JPL manages the Cassini mission to Saturn for NASA.
Thank you, and welcome to JPL. JPL designed, built, and operated the Cassini spacecraft for NASA. And as you heard about an hour and a half ago, transmitted its final signals from Saturn and then became part of the planet that it had been studying for 14 years after a 7-year voyage, for 13 years after a 7-year voyage to Saturn. But continuing the legend of Cassini, it turned that event into an event of hope. Not an end, but really a beginning. And the discoveries that Cassini has made over the past 13 years in orbit have rewritten the textbooks of Saturn, have discovered worlds that could be habitable, and have guaranteed that we will return to that ringed world. So the fantastic discoveries that continue to be made with the last set of ring-crossing orbits and in the grand finale of Cassini haven't really even been studied yet. And as Linda Spelker and I were joking earlier, the last few seconds of the Cassini mission are our first taste of the atmosphere of Saturn. And those last few seconds might be a number of PhD theses for students to come. So even this last few seconds, Cassini managed to continue its rewriting of the textbooks and its legend. And to talk more about Cassini and about the planetary program, I'd like to introduce Dr. Thomas Zurbuchen, the head of the Science Mission Directorate at NASA.
Well, we're here to discuss a magnificent mission that had an amazing end. And I want to do this starting with the big picture. I'd like to ask you to pull up the first picture. There it is. One of the most beautiful planets we can imagine. Some of the science actually kind of borders on sci-fi from time to time. We look at these images that are there and we wonder, wow, is that really how nature is? And yes, it is. Nature is really beautiful. This image, of course, taken roughly a year ago, shows the amazing planet, really the subject of the research that this spacecraft had. This is Cassini. Next picture. This is also Cassini. This is Cassini. Yes. A diverse set of people from all walks of life. You see at the top there, the science team at their last meeting just a few days ago, waving at the camera and really celebrating what they're learning, and of course recognizing that they're nowhere near done. Science will go on, and more discoveries will be made with the data, not just from the last day, but also from the last months. You see at the bottom, many members of the engineering team, which of course are a really important part of this as well. Together, if we added them up, close to 5,000 or so, individuals putting their heart and soul into this magnificent mission. This is, ladies and gentlemen, Cassini. And what you don't see there is that these people are representative of 26 countries or so. And of course, you know that the entire Cassini-Huygens mission involved 3 space agencies. And I just really want to call out my colleagues and friends from our sister agencies, and I want to really welcome you here and thank you for coming here. You're here, Alvaro Jimenez, the ESA Director of Science, my counterpart at the European Space Agency. Thanks so much. And Roberto Battiston, the president of ASI from Italy, a really important part of this design. Thanks so much, Roberto. Or grazie mille. Learn a little bit of Italian in Switzerland. The rest I forgot. For 35 years, you all have come together and worked to shed light on this most magnificent work. And I would say, with the words of a former governor here, we will be back. Thanks to Cassini, that we now know to be, this world that has so many facets to it, and many facets actually we did not expect. With today's end of this mission, we now know the planet's moon will remain pristine. So not only did we do science here at the very end, but we protected science to be done in the future. And we can and will, I'm sure, over time, find ways to go back to these moons and explore them, because the questions they have asked, make us ask, keep us up at night. Questions that are so deep, so simple, that every one of us can understand, whether or not we have a PhD or some kind of STEM education. Questions that are at the heart of an educated kind of populace of humanity as a whole. It's those kind of questions that will have motivated Cassini, those kind of questions that will motivate us to go back and explore again. Again, my shout out to the team. To me, what will stick with me about Cassini is the team in that room working together as one till the very end of this magnificent mission. Congrats to the Cassini and to its team. Thanks.
Okay, thank you, Dr. Zurbuchen. So now I will introduce our panelists for today. First, right next to me is Earl Mays, the Cassini Program Manager. Next, we have Linda Spilker, the Cassini Project Scientist. And next to her, we have Julie Webster, the Cassini Spacecraft Operations Manager. So now I'll turn it over to Earl.
Thanks, Jari. Maybe we could just reprise the last few moments in the MSA.
TS1, we just had transition to high rate mode, and we are in the atmosphere.
We have lots of signal that's actually advancement here events.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal at 115546.
Project Manager on FSO Quad. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project Manager, off the net.
There are times in this world when things just line up, when everything is just about perfect. A child's laugh, a desert sunset, and this morning. It just couldn't have been better. And if you think about that moment where we've been waiting for this entire 7 years, everything clicked out just right. And then we can step back and say the same thing about the Cassini mission. A superb machine in an amazing place, doing everything we could possibly do to reveal the mysteries and secrets of our solar system. This morning, a lone explorer, a machine made by humankind, finished its mission 900 million miles away. The nearest observer wouldn't even know until 84 minutes later that Cassini was gone. To the very end, the spacecraft did everything we asked. That ground system support was superb, and we believe we got every last second of data. It's already back in Arizona, and I think the analysts are already working on it. So we have indeed accomplished exactly what we set out to do, complete this mission with a Saturn probe. To the very, maybe just a little bit about the legacy of this mission. We've built the blocks, and both scientifically and engineering-wise, for the next set of missions. Europa will capitalize upon our engineering expertise and techniques and the instruments that we have developed for Cassini. 30 years later almost, will be that much better and more sophisticated and tuned for the environment that we're in. The scientific and engineering collaboration, I think, will be a hallmark for future missions. The fact that Cassini presented a unique set of challenges to the science and engineers. Of course, there's that lasting tension between science goals and engineering conservatism. But also, this put the scientists in contention with each other and with the engineers. And the mix of this as an experiment in sociology was an astonishing success. And I believe that the future missions are also going to learn how to cooperate and how to get the very best of their systems, well, with Cassini leading the example. We've been able to repurpose the spacecraft in all sorts of unique ways, and as you just saw a little while ago, we turned it into an atmospheric probe. So every piece of it's been used for to benefit of exploration. I've got to thank the many thousands of people. We had 3 space agencies, 17 member nations contributing to the launch of the hardware of the mission, hundreds of contractors, thousands of individuals in science and engineering. And we have to reach back, all the way back to the early 80s, for the folks that did those thankless cost exercises over and over again, all the way up to now, the people that sent the very final commands. Thank you, and the gratitude, I believe, of the world should be bestowed upon you for the accomplishments of this mission. We also need to thank our many millions of fans. The heartwarming buzz that we've gotten from social media, from the educational region throughout the world, the media, the more traditional media as well, has just been great. Telling the Cassini story, inspiring the next set of explorers, and is just absolutely as important to us as the scientific results we've found. So thank you very much for that. The Cassini mission ended this morning, high over the clouds of Saturn. The spacecraft is gone. Thanks and farewell, faithful explorer. But the legacy of Cassini has just begun. The effect that Cassini has and will have on the future of planetary exploration will go on for decades. Thank you, and long live Cassini.
All right, next up, we have Julie Webster.
Okay, thank you. I almost have no words. I was supposed to give the chronology. I've been on this mission since it was built, and as I gave several interviews yesterday, I'm one of the privileged few that actually sat inside this spacecraft before it was put together, and my last image was inside of the parts and the wiring as we went in. But we've had 13 years at Saturn, but 20 years of an incredible spacecraft that was designed by people, and I can't emphasize this enough, that had 30 years of experience when they designed it. They took all the lessons learned from the Voyagers and the Galileos and the Magellans and Mars Observer and built a perfect spacecraft. Right to the last end. The whole electronic system of the spacecraft ran at room temperature. That's an amazing accomplishment, and that speaks to all the individual engineers that built the spacecraft to last. The mission planning team and the navigation team that designed the trajectory to get the best bang for the buck with the scientists. And I remember the mission planners going back and forth with the scientists with, there was like 7 different trajectories chosen at this point. And I think the goal was to make all scientists equally unhappy.
That's right.
And the goal for our team, my team, and the navigation team was to make it last. And I think you saw this morning that we did. We got actually almost 30 seconds longer than we predicted. It didn't seem like it to me because it was in the flash of an eye. All night long, the minutes seemed like a long time, and then all of a sudden it was over. Cassini as a spacecraft could have gone on a long time, but it accomplished its mission at Saturn. We did everything that the scientists asked us to do, and we're really over. During that time, we traveled 4.9 billion miles. We did 293 orbits, all unique orbits around Saturn, shaped by the navigation team and by the spacecraft team, by the nav saying, point here and go change your speed this way, and the spacecraft performing it flawlessly. We did 360 burns. We planned 472 maneuvers. We executed 360, a little more than half of those on the main engine, the other half on the other part. And the last 21 weeks since April, I was a lot more nervous in April when we dove through the first time. I could barely speak, I could barely breathe when we were waiting for that signal to say that we got through inside the rings. And this last time, I have no words because it did exactly what it said it was supposed to do.
Even better.
Even better, even better, as it always did, as it always did. I can't. Radio Science, made the call for the end of mission, and I can't tell you guys. Radio Science they do these 30-hour long days, and I see them stay in day after day after day. Dr. Zurbuchen referred to the fact that Cassini will have questions for the scientists that will keep them up at night. Well, I no longer have a spacecraft that will keep me up at night. And I think after a few days, I think I'm going to really miss that.
Yep, no doubt.
And don't ask me tomorrow if I'm ready to build another one, but you can ask me next month. Earl thinks he has a hold on me for a year to write the engineering report, and we've got 20 years of test labs and flight hardware and support hardware and a team of 150 people to disperse and break down, but right to the end, it did everything. And a lot of the team is in here right now, and I want to thank again the navigation and the spacecraft team, the real-time operations that also worked the thankless hours that were the ones that called me in the middle of the night. It went perfect. It did everything it asked us to do, even when it didn't do it. It was because what we told it to do.
It was our fault.
It was our fault. It still was our fault. It's perfect. It's perfect. And it's, I played the Moody Blues, my wildest dreams, coming in and out of the lab the last few days. So I'd blast it in the car going home, and I'd blast it coming back in. This has truly been beyond my wildest dreams.
Great. Thank you, Julie. Okay, and now over to Linda Spilker.
Well, for me, this has been an incredible journey with Cassini that spanned 30 years. I was with the mission from when it was just an idea after the Voyager flybys, and now to see it through to the end is truly amazing. And to share that with my family, my personal family and my Cassini family, what a wonderful experience. When I look back over the Cassini mission, I see a mission that was running a 13-year marathon of scientific discovery. And this last orbit was just the last lap. And so we stood in celebration of successfully completing the race. And I know I stood there with a mixture of applause and tears because it felt so much like losing a friend, a spacecraft I'd gotten to know so well. And yet in looking ahead, both an end and a beginning, there's so much left, so much incredible science left to figure out and understand, decades worth, science that will span a generation. When I think about Cassini going in, I know that there's a piece of me there in heart and soul, because I know we signed our signatures on a list of sheets. Those sheets were scanned in and put on a CD. And that CD is on board Cassini. So a little piece of me went into Saturn's atmosphere along with Cassini. So what an incredible ride. And just lasting for so long. I want to step back just a little bit. If we could go to the first slide, please. This is an image put together by our visual and infrared mapping spectrometer team. They did a spectacular job turning around this data set that just came down last night. And this is a view in the infrared at 5 microns. You can see the heat energy coming out of Saturn. And this is the place where Cassini took its final plunge. And if we go to the next graphic, see a little air ellipse there? That's where we think Cassini went in to the atmosphere of Saturn. So, what an incredible ride. And to get that was the very last set of VIMS images that came back from Cassini. And so here it is turned around very quickly for you to see. If we go on to the next set, we had our last downlink of images. And I'll just look at this and you can share what we saw for our final set of images and data. Saturn, Enceladus setting behind Saturn. How beautiful. Part of the mosaic of Saturn and the rings in color, our last look at this incredible system. Titan, you can see the lakes and seas at the North Pole and the haze at the limb. An even better view of the lakes. There's Daphnis creating its wake along the edge of the Keeler Gap and the beautiful structure in the rings. Another view looking out across the rings, the bright B ring, the dark Cassini division snuggled next to it. Views that we're going to miss for a long time to come. That little tiny propeller, that little object just above the dark gap, a large set of ring particles together trying to force open a gap. And here's Cassini's final image. So what an incredible, incredible, wonderful set of data. And as we went into the atmosphere, we had 8 of our science instruments on, including the ion and neutral mass spectrometer. We had the magnetometer. We were collecting gravity data there to answer questions about Saturn itself. But in particular, trying to understand, as we probed deeper into the atmosphere, the hydrogen to helium ratio. You can't measure helium unless you're directly measuring. You can infer it, you can model it, but to be there and directly measure and sample, that was absolutely amazing. And so that team is hard at work right now, looking at their data and trying to assess what they saw in those very final moments. And I'm sure they'll be very happy that Julie was able to get the spacecraft to survive those extra seconds as we plunged on in. And then, of course, the longer-term analysis, as I said, that will go on for years. And I just want to thank everyone as well, in particular the international science team. A lot of them are down at Caltech. We had too many to try and fit all at JPL, and so they're down, and they've been celebrating, and I've heard having a great time from the reports I've heard. And also to thank the public, as Earl said, who have come along with us. And when I think about Cassini, I think Cassini's final gift to humanity was the fact that we knew the day, the hour, the minute, and now the second of the plunge. And so we could gather together with the scientists, the engineers, with the public, with our own families. You can think of us as a giant worldwide Cassini family and share this final moment of the plunge and have that memory to add to our Cassini scrapbooks. And if I had one thing I could say to Cassini, I'd say, goodbye, Cassini. Thanks for the ringside seat at Saturn. And as Thomas said, we'll be back. Thank you.
Okay, thank you, Linda. So we're now going to go into the question and answer part of our briefing. So a reminder for reporters on the phone, press *1 and you'll get put into the queue. We'll have social media questions with hashtag AskNASA. And anyone here in the room, if you'll raise your hand, we'll bring a mic around and you can stand up and ask a question. So do we have any questions here in the room? We have one right there.
Hi, thank you all, and congratulations. Calico Field with Space.com. I know it was a long shot, but just wondering if any of those telescopes in the, over by Australia and in that area actually saw the flash of Saturn, of Cassini going into Saturn.
I haven't heard any reports back about that yet, and it was a long shot, and maybe we'll see something.
And I was wondering if you could also just mention, because you mentioned the science instruments going into the planet, how much hope do you have that those measurements are going to help you finally figure out the internal rotation rate of Saturn and the length of the day?
Well, Michelle is here, and she's looking pretty grim, but I know she's going to work really hard to figure that out.
Oh, we're going to get you a mic, Michelle. There you go.
I mean, one of the things that we were hoping is if we take data for as long as possible on the way in, that will get us closer to the planet than anything's ever been. And we need to do that to be able to try and resolve the tilt between the dipole and the rotation axis. I'm hoping we can do it. I'm not going to promise, but ask me in 3 months' time. Give us time to analyze the data.
We have some other questions over here. Emily?
Emily Lakdawala from the Planetary Society. We were watching two graphs right down toward the end. One of them flatlined a little earlier than the other, and the bottom one seemed to kind of go up and down a little bit. Can you tell us what was happening? What were the two different ones and what was happening there?
You were watching the radio science signal, the carrier. The actual X-band carrier was the top one. That's the one that's the 8 gigahertz signal that we have our telemetry on. And the other one was a radio science signal that was coherent with that at 2 gigahertz down lower than it. So we expected that the S-band would last longer than the X. The X is when we cut off the telemetry, but because the X has a wider beam width pattern, that it would last. And you may, I don't know if Asil or Elias can answer that, you may have seen a couple of side bands coming down for the S-band. They have pretty dramatic, and you might have seen a little on the X, but it goes way down into a first null in less than a degree, and then it might have bounced up after that, but it was a sideband of S-band.
Okay, sorry. Sarah?
Hi, Sarah Kaplan from the Washington Post. Linda, you showed us that image of the infrared image of the spot where Cassini probably disintegrated. Can you tell us anything about that spot and sort of situate it on Saturn?
Yeah, I haven't looked in any detail. Maybe Bob Brown, who's back here, do you know anything about that region of the atmosphere, Bob?
Thanks, Bob.
I guess I would call it J-random Saturn atmosphere around 10 degrees latitude. We found out we had an opportunity to image that site a few months back, and because the impact took place on the dark side and because we can see in the dark, what you see there is the thermal heat image from Saturn. It's the heat leaking out of Saturn's interior. We took this shot, and luckily we got it.
I'm sorry, when was that image taken?
About 15 hours ago.
Thank you.
Okay, great. Any other questions in the room? Okay, we're going to go to the phones. We have Marcia Dunn of the AP on the line. Please go ahead.
Yes, hello, thank you. I'm just wondering, if the toasts have begun yet. Is there champagne in store for the team this morning or afternoon? What's next for celebrations?
Well, the science team is going to get together later this afternoon, and we're going to get together and celebrate and reminisce about the good times on Cassini. You want to talk about the flight team?
The flight team is going to get some sleep, and we're going to get together on Sunday afternoon. But I don't think we're going to wait until then to open the champagne.
Okay, well, let's go to some social media questions. Kendra?
So Nancy asked, as Cassini's journey ends, what questions do you have left that you would like to see explored in future missions to Saturn?
For future missions to Saturn, I think there are a lot of possibilities. One certainly involves the tiny moon Enceladus and the potential for life in that global ocean. Is there life in that ocean to go back with the instruments to sample through the plume? Titan, the potential for astrobiology in the oceans on Titan, to have something perhaps to land and figure that out. Also the source of methane in Titan's atmosphere that keeps the atmosphere as extensive as it is. The hexagon, what's keeping it going and going and going, like the Energizer Bunny, it just keeps going. Also, there's questions about the rings. Can we get even closer and look at those individual ring particles to try and understand what's going on? So lots of questions remain, and that's why I say we have to go back.
Let's take another social media question.
Sure. Parth is asking, which is a great follow-up, what is the next probe or spacecraft that will be sent to Saturn?
Ooh, we'll have to ask NASA about that, Jim Green about that.
Oh, sorry, well, can we get a mic to Jim Green, please? Oh, there we go. Yeah.
So I'm Jim Green. I'm the Director of Planetary Science at NASA, and currently we're conducting a competition we call New Frontiers. And in that call for proposals, we included Enceladus and Titan. So hang tight, going through the evaluations now, and by the end of the year, we'll start announcing what are some of the finalists that we'll look in greater detail at.
There's also a Saturn probe mission, I think, in that.
There's a Saturn probe? Yes, thank you very much, Linda. There is indeed Saturn already for decades in terms of being able to get into the clouds and really understand its composition and much more about it. Saturn probe was also on that list. Thank you.
Right, and Cassini was really sort of a micro probe, just looking at the very top level, and so this probe would go much deeper like the Galileo probe.
Okay, great. Just a reminder again, if you're on the phone, *1 for reporter questions, and if you're in here, raise your hand. We have a follow-up question here.
So Emily Lakdawala with a follow-up. What does it mean that you had this signal for 30 seconds longer? Is that just the usual overperformance of the DSN in locking on the spacecraft, or does it mean that the spacecraft was able to fight the atmosphere for longer?
I think it's a little bit of everything. The spacecraft, I think we did come in a little bit later than we thought, and that just didn't delay the demise, it just delayed the start of it. But we also thought the DSN has just been phenomenal. They've been tuned in as well as you could. And the spacecraft, all of our modeling is we don't have any real world experience with this. And so to be within 13 seconds of our predict is, for us, that's a hole in one. So.
Okay, let's, we have another reporter question here. Oh, she's coming right behind you.
Thank you. Lisa Grossman from Science News. Can you just confirm what the actual times were for the atmosphere insertion and then loss of signal? Because are they different from what was projected?
Yeah, it was 11:55:39 for the X-band signal, which also caused the telemetry, and 11:55:46 for S. Loss of signal.
And we had predicted, much to my embarrassment, yesterday's press conference, I called it.
That's UTC also.
Okay.
So it's 4.
We called 4:55:16. I unfortunately announced 06, but the baseline we were working from was 55:16, and we lost X-band at 55:39, and that essentially is when we lost data. The spacecraft, of course, was going to last longer on for at least another minute, and of course the S-band did go a little bit longer.
Okay, let's take another question from social media.
Sure. This question is from Orion. Do Cassini have only options to rush into Saturn? I would like to know if there are other ideas that have been considered.
We had lots of different ideas, and what really came down to it, let me just give you a few of the different flavors. We could have left the Saturn system altogether and gone to Jupiter or out to Uranus. Those were very long missions, and we would not be chatting about them, and probably our children would not be chatting about them. They're very long. And there were several options, so those were discarded pretty much immediately. But as an exercise, could we leave the system? There's also a Centaur asteroid mission that was actually achievable. Staying at Saturn, we could have gone into, first of all, if we stay at Saturn, Cassini spacecraft must be put into a safe place. There are international treaties that require us not to leave an untended spacecraft in the inner system where it might inadvertently collide with Enceladus, which we know is just rife with all of the materials for life, Titan, or any of the other icy satellites. So if we stayed inside the Saturn system, we had to dispose of the spacecraft somehow. Well, then it becomes, where's the best science? Well, it's inside the Saturn system. It's not way out at the edges. It's inside. So 7 years ago, we began a mission that planned to use every last kilogram of our propellant and finish up exactly the way we did. We knew that these final 22 orbits were very risky, so we didn't want to put them in the middle because we would maybe not come back out. As it turns out, they weren't anywhere near as risky as we thought, so we could have done a lot more. But, that's all hindsight. So there were lots of other options, but this was by far the best. Cassini going out with an empty tank of gas at the very top of its game in a scientifically unexplored environment.
Great. Okay, we have another reporter question in the room.
Hi there, Steve Futterman from CBS News. I want to ask the three of you a question that's not really concerns the data or what you've discovered, but just sort of the human side of this mission, this spacecraft. We all know the story of Pinocchio, the wooden doll that becomes human. I'm wondering what was going through your heart and soul today as this came to an end. I'm not suggesting it became like a child to you, but what did Cassini mean to you? Did it hurt today?
Yes, it does hurt. I mean, what can you say? We've been with this spacecraft off and on since launch. I haven't been on the mission the entire time, but I helped build it. I helped launch it. I've been through 20 years with it. It is an extension of ourselves. An extension in kind of the more anthropomorphic sense, but also in our senses itself. We are out at Saturn every day. We get a call back home. We get data. We get images. We know what's going on out there. And that is an extension, I believe, of all of us. We believe of ourselves. And so that's gone. There's a loss. If I can talk about it being a robot it finished the end of its serviceable life and needs to be put into the junk pile. But, and that, of course, there's an element of truth to that. There's also an element of truth that has been our companion and our dutiful servant for for several decades. And so it is a loss. But there's also a sense of serenity and peace with that because we've done exactly what we believe is the correct thing. And so it's a whole potpourri, you name it.
Yeah, I think for me there's a core of sadness and part in thinking about the breakup of the Cassini family, coming into work on Monday morning and knowing that there'll be empty offices there and the people I could just stop by to chat with will be off and doing other things. But it's both an end and a beginning as these people go off and work on other things. But I also feel a tremendous sense of pride to have worked on this mission over so many decades and to see the fruition of this particular mission. Although part of the sadness is thinking about, Cassini has revealed Saturn as familiar as our own neighborhood might be. And now, for a time, until we go back, that's a distant, very distant world now, just like a small little world in a telescope. And those details of the rings, those tiny moons snuggled in so close, those are all gone until we go back.
I think it's the loss of the day-to-day. We're in the trenches working this all the time, with a core team of people that you see every day for 8 hours plus, and sometimes a lot longer than that. And I don't know, did Earl say that we stepped on, that the Celestial Mechanics does not recognize U.S. holidays or European holidays. We stomped on every Christmas, every Thanksgiving. We were always either doing a maneuver or something went wrong with the spacecraft. And so for our families, maybe they will be glad not to have the pager go off in the middle of the night or in the middle of dinner going, oh, sorry, I got to run. I got to go take care of this. And it's the loss of that camaraderie. I think for me, and I really thought I was going to be more sad about the spacecraft, but you can't, I'm not. The spacecraft did everything we asked it to do, everything, right to the very end. That's all you can do for anybody. That's all you want for any human, let alone, a robot.
Did any of you have tears today? If I can be personal?
Earl started it. He did have tears.
I think we messed it up a little bit. I must admit, it was a very emotional moment.
Yeah, I think tears and applause at the same time, and I had a little purple hanky there, to be able to use. So, tears and applause.
Okay, we're going to go back to the phones. We have Leo Enright of Irish TV. Go ahead.
Thanks very much. I wonder, could I ask a question of Alvaro Jimenez of ESA?
Yes. Why don't you come up to the podium here?
Thank you very much.
Yep.
What I wanted to know really was, when we look at Hubble, we look at Cassini-Huygens, we look at SOHO, all these great collaborative missions between the United States and Europe. I wonder, what is the prospect of us ever, frankly, doing these sort of great collaborations again? Is it going to happen, or is it more likely that Europe and the US will take slightly more independent paths?
Well, we are very proud of actually having collaborated with NASA in this great mission. And we are determined, we are convinced this is the way to go. We have to work together to really be ambitious and achieve missions like this one. This could be in different fields. We have now, as you have mentioned, JWST to be launched. This is another great mission where Europe is deeply involved with NASA. We have the experience of Hubble. We have missions, though, and that has been a little bit of a change, where also are led by ESA, but NASA is participating also actively, like JUICE to Jupiter, and we are looking into all kinds of possibilities. Now, we would like to have more and more cooperation, and I think here we have an example to follow, which is Cassini-Huygens, where it is important to have the same goals, but also define well clean interfaces, clean management structure, how the mission is led, how is put in place, and then making it a success. So I'm really making sure, because we have, and this is something you can see in Europe and in the US, our scientists, the scientific community is totally mixed. They are working together already, regardless of what the agencies do. And if they work together, we are servicing our scientific community. We have to work together.
Okay, great. Thank you. Okay, all right, thank you. Okay, so why don't we go back to social media?
Sure. President Buff asked, what was the most surprising reveal? And have any of you named a child or pet after Cassini?
No.
No, child or pet named after Cassini.
We have named some of the features in the rings after our pets.
Yeah.
That's true. Larry raises a very good point. Larry's with the ultraviolet team, and some of the features have been named after cats, pet cats.
I do remember hearing one of the engineers telling me that he named his daughter Phoebe after the moon Phoebe. So, okay, let's take another social media question.
Jason is asking, what do you feel is the most valuable contribution of the Cassini mission to science and space exploration?
Well, there are probably two answers. I'll defer the science question to Linda, but I think in terms of showing a path forward in space exploration, the techniques that Cassini has developed in astrodynamics, celestial mechanics, mission design, in engineering, and as I mentioned in my earlier remarks, in just being able to manage an extremely complex system to the ultimate of its capabilities. And I might also add the importance of a flagship, a mission that has a full suite of instruments ready to deal with whatever it finds. There's always room for the tactical missions with a focused instrument, but something that's ready to deal with whatever it finds and then go back again. And we have stories over and over again where one instrument has revealed something about Saturn or its moons, and the other instruments have all piled on. And we get from a little snippet a full picture of the entire thing. So the value of flagship, the engineering techniques and management techniques that have been exploited, I think will lead the way. Okay.
I would certainly agree with Earl to have that full toolbox of instruments available to follow up on the unexpected discoveries. And as far as Cassini goes, I think one of the biggest legacies from Cassini will be the fact that we now know that there are ocean worlds not only around Jupiter, but also around Saturn. You have Enceladus, Titan, perhaps Dione, sort of opening up our view of where could we find life in our solar system. And maybe it doesn't have to be in that narrow zone, the Goldilocks zone where the Earth is, but could be elsewhere, and the implications forward for exoplanets as well.
Okay, we have a couple of other questions. The gentleman in the back there. Hold on, wait for the mic. Here it comes.
Hi, my name is Neville. You had on board the Cassini something that could, quote unquote, sniff the atmosphere. Was it a hope or an absolute plan that you would be able to utilize that?
It was planned to use that, the ion and neutral mass spectrometer. We've used it very successfully for Titan's atmosphere, for looking in the gas from the plumes from Enceladus, and also earlier orbits where we had sort of dipped our toe into the atmosphere of Saturn. So we knew it would work and continue to work, and we just wanted to keep getting data back as long as we could to get those very last seconds, the deepest data that we could get.
Let me just pile it up for a second, because when we launched, the ion and neutral mass spectrometer was going to be used for Titan.
Right, that's it.
We got Enceladus, and we got in Saturn, again, because of the fact that we were able to find these mysteries with other instruments and then use this mass spec in a different way. So again, it's just the point. If you can fit it on, Jim will probably shoot me for this, but if you can get it on under price, get the ride.
And that's kind of the point of my question is you're building into these missions serendipity with the anticipation that it could maybe be used another way.
Absolutely. You have to, even a very tactical mission with a single objective and a single instrument still has got to be ready to roll with the punches or the surprises. It's just that Cassini happened to be so superbly built for that, because if you see something with one instrument, then the entire might and majesty, the entire spacecraft can be brought onto it and reveal it. And Enceladus, I don't have the time to go into the story of how many instruments it took to reveal that entire story. It's the entire spacecraft.
I think it took every instrument on the spacecraft working together to reveal what we know today about Enceladus. So, every single one.
Okay, other questions in the room? The gentleman here in the front. Oh, here. Yes.
Hi, I'm Kurt J. Mack. I'm here with the NASA Social. A lot of the pictures from Cassini were uploaded online in real time, the raw images, and were taken by amateurs and people online and stitched together and almost finished before the scientists got a chance to do so. I wonder if that was an expected outcome and if that impacts the way and the decisions made during the mission and perhaps future missions for such images.
We love it. We love the amateurs to get out there. In fact, I think Emily Lakdawalla here was one of the first to put together a movie of Enceladus setting behind Saturn. I think I saw it last night, so she got those images and put them together right away. We love it. That's what we want to do, is involve the community.
There's a small community that's been doing this to us for years, and so we don't even try to get ahead of them anymore. We are scooped the minute, and that's what Cassini's always been about. Get the images out. It was a decision from NASA a long time ago. As soon as they're on the ground, everybody gets to see them, and then do what you will. And we've got some great graphics. They're better than ours sometimes.
And faster.
I have to be careful about that. They're faster. They're faster than ours, you know. And so it satisfies that need for the immediacy. So.
All right, well, we're reaching the end of the hour here. So we're going to do a playback of the graphics that you saw in today's press briefing, including those last wonderful images that Linda showed earlier. We're also going to add some additional Saturn imagery onto the feed. So thank you, everyone, for helping us say goodbye to Cassini and to Saturn.
is enthusiast 1. We just had transition to high rate mode, and we are in the atmosphere.
We have lots of signal at X-ray band and zero band.
Project manager, flight director.
Go ahead.
Okay, we call loss of signal at 115546.
Project manager on FSO Quad. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project manager off the net.